Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So it's good to be back here to meet with everyone here. And before this part, we were talking about the entity relationship diagrams, and we were also talking about databases, the basics of databases. So that's why we got into here. You can see here the systems framework, and we were talking about the focuses on data, on system data from the perspectives of the owners and the users, where you can see here the owner would be giving us the entity, the let's say the titles of the database files, or it could also be the entities that interact with the system. And then from there on, we are to identify the relationships between those entities, also the attributes of those entities. As you might remember the example here. Now we'll talk more about how to design the actual database files or database tables based on these ideas. First, let's take an example of an entity relationship diagram for the e-commerce site called Tokopedia. This was made by Group 5 in a previous session. Now you can see here the entities are customers, products, sellers, shipping service, and method of payment. These are the entities. And here you have an associative entity, an entity which is not an actual separate entity itself, but it would be connecting between different entities. And next to the entities, you have the attributes, or later on in the database file, you would call it fields. And then the blue one here, these are the key fields, the identifiers of each database file. Okay, let's take a look at how you read this. First, the customers. The customer, so one customer can make several dealings, can buy several things. That's why a customer can have one or more than one transaction. But for each transaction that is noted, it belongs to only one customer. So if you give a receipt, if you print out a receipt, that receipt only belongs to one customer. It could not belong to several people in one receipt. That's what's called a transaction here. And then you can see here a specific product can be bought and then noted into one transaction, or it could be noted, it could be included in other transactions as well. So it could be one and more than one transaction. Now here, one transaction, okay. Now this is not really correct, because if you were to put it like this, then for instance, if you bought bread, you can only buy one bread to put into that one transaction. While in real life, you could buy several loaves of bread. So it's not one and one here, one to one, but a transaction can have one product or more than one product. It's also more clear if, for instance, in one transaction, you would want to buy bread and also peanut butter jam, for instance. So this should be one to many. And then one transaction, okay, can have, let's say, only one seller. Now, it depends on the type of transaction. Okay, if it's an online transaction, and then for instance, every time you buy from another seller, and then you might want to give a different transaction with a different transaction number. Okay, but it's also possible to make it easier for the customer, even though that customer buys several different items from different sellers. They might want to put it into a wish bin, or wish bin, or let's say a cart, a shopping cart from different sellers, and then you can just put it into one transaction, and later on, each individual product would be sent, their records and also the payment would be sent to the respective sellers. That's also possible. Or one transaction could also have just one seller. If there's another seller, you would put it as another transaction. So that's based on the strategy or the rulings of that particular company. And then in terms of shipping service, okay, one transaction can have only one and one only shipping service. That makes sense. Everything uses Tiki or DHL, UPS, and so on. And then one shipping service could cater to more than one transaction. Okay, because of course, one delivery company would be available for several transactions. And then the payment method. Okay, for each transaction, only one payment method is available. That makes sense. Because for instance, for this one transaction, you just want to pay using credit card. But for instance, if you want to pay combined credit card and debit card, for instance, your credit card is has reached its limit, then you have to separate it into a different transaction. Okay, so this entity relationship diagram is most of it correct, except probably for this one, for the product here. And then maybe not really exactly the same like this, but now we would be giving an example on a physical store, a physical supermarket. Okay. And a system or an application, part of it would function as a tool to print out a receipt. So this is an example of a receipt from Walmart. This is a supermarket. Here, this is an example of a restaurant. So let's take a look at the restaurant first. Okay, this is the name of the restaurant. You have the address, you have the customer name, you have the date, you have the invoice number, time, and so on. And here, take a look here, you have the item. The item is Foodman Burger, Ginger Ale, Diet 7-Up, and so on. What is it? A description about the burger using medium rare onions, and so on. The quantity you have here in one specific column, and then the price and the amount. And then you have down here subtotal, tax, sales tax, others, and the total, the grand total here. Now this is different from this one, from the one on the left, from Walmart. This is the one that we would want to try to emulate. Okay, what are the items that you can see here in this receipt? You have the phone number, the name of the manager. Now here you have because Walmart is a chain of supermarkets or department stores, then it has several stores. This one in particular is from Tampa, Florida. The zip code is 33604. And let's try to understand these symbols. Okay, so ST hashtag. This is store number. Okay, in Tampa, Florida, it's store number 5221. That's the store number of the store in Tampa, Florida. And then this is the operator number. The hashtag here means number or ID, identification. Okay, the identification number of this operator, the person who inputs the data into the cash register, is 00001061. And then you have the teller. This could be the line, the cashier line that customer goes into, 06. This is the transaction number, 05332. And then aside from that, you would also need to know the date of transaction. It's put here, 11 June. And at 2:21:54 in the afternoon. Now, what did the customer buy? The customer bought bread. Now here you have the product ID. In the restaurant here, you don't have product ID because probably the number of products they have is quite limited based on the menu. But in a supermarket, you have hundreds of thousands maybe of individual items. So that's why you have this. Now, note here that it's a very long number, meaning that they are expecting the number of products to be in this range. So this is hundreds, thousands, millions, and then it could be up to 999 billion types of products that's available in with these digits. So of course you would have to identify the amount of items that are possible, and then you have to determine how many digits is needed. For store ID, it would be a maximum of 10,000 stores minus 1, because you wouldn't want to have a store numbered 0000. The number of operators, it seems that they're anticipating in the future they might have 10 99,999, okay, almost 100 million operators, but probably only a maximum of 99 checkout lines. And transactions, this might be per day transactions. Okay, so here you have bread. It's bought 2 times. And then this is the price of the bread. This is different from here. In here, you write quantity as 2. You don't have to write it several times. In here, they do put it several times. If you buy peanut butter 4 times, then it's mentioned 4 times here. Okay. For this, this is Jiffy is Godiva, for instance. It's the brand chunk chicken chunks. Okay, this is bought 2 times. That's why it's shown also in the receipt 2 times. And then you have the subtotal, the tax, the total, debit, meaning the number of the amount of money probably that is given, and no change because the customer paid an exact amount. Now let's trace back. Let's reverse engineer to find out how the database looks like. Now, remember first, in a system, you would have input. You would have processing of the input. Data goes into the system, it gets processed, and you get the output. Now, for that case, the process is done to the database, to the data in the database. In that case, the database file should have all the data that is needed to make this output. So if this is the output, then what are the fields that would be needed for the database file. Let's try this out. Okay, so here, let's see whether this is correct or not. Here you have the store number. Okay, you have store number here. You have operator, you put it there, teller, transaction, product name, quantity, price, subtotal. Now, is this properly designed or not? Do you think all the data is available or not here? The data needed for this, and maybe not just for making the receipt, because making the receipt is just one part of the function of that system. So you might want to have other functions as well. Okay, so is this enough or not? And then what is the entity? Because every table needs an entity. So the entity would be the title of the database file or database table. Now, what is the entity for this database file? It's not really clear. Is it store, operator, teller, and so on? Which are the key fields? So couldn't really figure out which is the key field and which are the primary and foreign keys. So let's try to put some data here. Based on the receipt here, you have the store number 5221, all of it is from 5221. This is the operator, all it's still the same operator, same teller, same transaction number. Okay, if you put it in this way. And then you have the product, these are the products. And then you have the product name here. You have the quantity of the product, the price, the subtotal. Now, there are some problems if you would be showing it this way, if you would be using this database file. All the data is available, that's correct, but the entity is not clear. What is the entity here? Is it store, operator, teller, or which one is it? It's not clear. And then you can see here, the attributes, several attributes would have to be inputted repeatedly in each record. So in one record represents one entity, right? If this entity, if this file is about, let's say, store, then it should be one row here explaining about one store. It's not about this one store. It's not about this one operator and so on. So, and then in this case, you have to write down again 5221 and the operator number, teller number, transaction number again and again. So it's not practical if you input it, and then it doesn't also save space. It wastes space in the database. And then, of course, once again, the primary key. Which is the primary key? If you don't have a primary key, you might not have a foreign key, and then it would not be a relational database then. So you couldn't relate this database to another database. And then it would be hard to expand the database. If you were to make more functions, to add functions to the information system here, then it's rather hard to do because you wouldn't be able to easily add on the database. Remember that the traditional database might make, for instance, a new application, a new information system with a separate database. This, if you put it like this, you might need a different database if you were to make a new application. So that would not be easy and not practical, and it would be you can remember the shortcomings of the traditional database file system. It would be hard to expand. Also, here, this is redundant. You have product number, and then you have product name. So this is redundant. And then what if, for instance, you have a change in the price? The price is 288. What, for instance, happens if the next time you buy bread from your supplier, the price changes to 295? It's not that much of a difference, but it is a difference. And if thousands of customers buy it, then you would be losing money if you can't change it. So you need a place to change it. And then here you have the subtotal. Are you sure that the subtotal has to be recorded for every transaction? Because the data is already there. So what you need to do here is you need to do a process called normalization. So you would have to break it down into several database files and then make sure that it becomes a relational database. And it would look something like this. Here you can see there are two parts of it. Okay, from here, you break it down into transaction number and then payment. Most of what you would be thinking about the receipt would be in the payment here. It would have the product here. And then this is the item, the table that you would be constantly filling in, inputting the data into this database file. Well, here, you don't always put it in. So it is still dynamic. You only put it in every time you have a new transaction. Okay, every time you have a new transaction, you just put it in once. For this one transaction, okay, take note that the entity is called transaction number. That's the entity. That's the title of this database file. In that case, one row here, this would be explaining that certain transaction number. For transaction number 05332, the date is on 11 June. The time is 2:21, store 5221, operator, and so on. This is for one transaction. Another transaction would have a different transaction number, a different time, maybe date, still same store in this case, maybe a different operator and a different cashier line number, maybe a different payment method, and so on. For that one transaction. For this transaction, there are 3 items that are being bought. Now here, there are actually 2 ways to show it. If you remember here, this one, for every item you buy, you put it once. So you, if you buy 4 items, then you would be showing it 4 times. In here, you just put quantity, how many you buy. So there are 2 ways to do that also in the database file. So you have here, this is mentioned 2 times, but you can alternatively also just write 2 here, 2 bread, 2 loaves of bread without having to put it several times. So if you remember, if you go to a cashier, you might be buying instant noodles, let's say 5 of them for the whole week. And then the person, the cashier does not have to input it one by one, but he scans or she scans the barcode and then writes the number 5 for saying it's 5 items, 5 of the same items that are bought. That's the quantity. So you can also just write the quantity is 2 here. This is 1 and so on. And then, of course, this needs more data. So what is store 5221? Who is teller 06? Who is member 043978? So that's why you have here more database files. And these are relatively more static than the ones on the top. These, every transaction, you have to fill it in. You have to fill the attributes of this entity. Here in one entity, you have to fill in several attributes here. Okay, so please note here that the transaction number is written again because it's in one transaction. In one receipt, you have several items that are paid, so that's why you have to put it again and again, except if there were only one item bought in that transaction. Okay, let's see here. You have what is this product number. Okay, you have product number so and so is bread. The price is $2.88. This one is peanut butter. $3.84 is the price. What about the store? Okay, so remember, this is a primary key. This is a foreign key because this key field is taken from another database file. But in this database file, the store database file, store number is the primary key, while in the transaction number file, store number is a foreign key. You have the explanation. It's the store in Tampa, Florida with the zip code 33604. What about the operator 1061? Keep in mind that there are several zeros here, like we observed before. Is because there might be in the future, let's say up to 100,000, almost 100,000 operators. So that's the amount that it would enable. If you don't think there would be that many operators, you do not need this many digits. Okay, it's Albert Einstein, okay? And you can use it for another purpose as well. The operator, there's a performance measure of the operator. So aside from making an application for the cashier, you can expand it into an application for defining the performance of each operator. Later on, you might add a bonus for performances that are above 75, for instance. And if a person is consistently above 75, that person might become employee of the year, for instance. For member, here, it's connected to this database file. This is the primary key. This is a foreign key connected to the primary key here. Now, the good thing about just expanding one database file, remember, we're just adding this database file connected to this column or this field, okay? You can expand it into a system which would cater for the members. So you might be able to make a customer relationship management system based on this database file, because you, of course, it's not just this. It could be name, the street address, city, zip code, date of birth, and so on. And then one of them might be points. So then you could send an email to members that have received more than 700 points, and then tell them you are given, let's say, umbrella as a bonus, and then please pick up your umbrella in the Tampa, Florida store. Or let's say based on the date of birth, you might be saying, hello, happy birthday, for instance. For this special day, you would be getting a 10% discount on all of our products. Okay, so that's good to engage members for customer relationship and management systems. And you can even add even more, like this, for instance. By writing the stock, okay, this actually you could put here, here, aside from price, you can also stock, but you can also put it into a separate one and add more. For instance, you can add a field called supplier number. Okay, so you would be able to find out who the supplier, the supplies are taken from. Here, for instance, you can add one more, supplier ID, in this one, in this database file. So in that case, you can have the stock. And then if you are running out of stock, you know which supplier to go to. And what is that supplier? And then this supplier is Orchard Company with the address and so on would be here. So then rather than just making it into a cashier system, you have added several other systems. For instance, this is a human resources system or salary bonus system. You have a member or customer relationship management system. Now you have a warehousing system or a procurement system. by just adding one database file, and it's so practical. Okay, so this is the basic idea of the flexibility of database management systems. You just add one file and then you can make a new system. Now remember, the data itself is in this database, but how you use the data, that's the part of the information system. What do you do with the members? What do you do with the performance of the operators? That's in the programming, in the information system, or in the application. Okay, so but of course the database should enable the functions that are needed in the information system. So I hope that was useful. And let's expand, let's practice more with different types of systems and different types of databases. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.